that. And yeah, just want to say a big thank you for everyone coming to this session this afternoon. It's a real privilege to be here at the UC and having a chance to present to you and specifically sharing on how we've been able to empower 3D planning for Victoria's future. So as mentioned, I'm from Australia. My name's Justin, I'm the manager of the Spatial Services team in the planning department in Victoria, Australia. There's a huge amount of growth and development going on across Australia right now. And that growth and development, specifically in Victoria, has presented us with a really good opportunity to leverage the 3D spatial technologies that are available on the market, and specifically to support the planning work being done across the state. And so it's that journey of developing a 3D spatial solution for planning that I want to share with you today. Now, just to put things into context, my team's made up of 17 spatial professionals, which I'm guilty to say are all back in Melbourne working hard while I'm over here at the UC enjoying the beautiful weather. I think it was very cold this morning in Melbourne. But yeah, amazing team, and we're responsible for a range of things, but basically our core responsibilities are to manage, to provide all manner of spatial services and support to the planning department. Some of the key responsibilities that we have include managing the Victorian Planning Scheme spatial data set. We provide high quality cartographic products for planning projects. For instance, that map in the top corner there, which really proud to say that was actually accepted into the Esri map book this year. So if you have a look at the map book, you'll see one of our maps in there, which is pretty exciting for the team. And we provide the Minister for Planning with the ability to review or visualise planning permit applications across the city. And it's that last point which was an early driver for a 3D solution for planning. As planning permit applications come into the department, our planners need that ability to visualise how those new proposed developments are going to look. For instance, undertaking overshadowing assessments or visibility analysis. And if you pair that work with the precinct planning work that we do, you start to see why 3D is really critical in our space. But before I go too much further into those details, I want to wind the clock back to the start of our journey and talk about the steps and missteps that we took along the way of our implementation. So, up until 2019, we were operating on a 3D platform that was a black box. It had no spatial integration capabilities and a really limited roadmap. So the time had come for a new 3D solution for planning. But to ensure the implementation was delivered with the best chance of success, we undertook the project across 4 steps, and they were, firstly, sitting down with our planners to really understand their requirements as opposed to just recreating what they already had with that old implementation. Following that, we undertook a market assessment of the technologies that were available to us, and then implemented a targeted proof of concept to put our preferred option through its paces. Once we were happy with our selected technologies, we got into the formal design and implementation and rolled out version 1.0 of the Planning Group's 3D platform. And as the usage ramped up and the use cases started to roll in, we expanded the functionality and rolled it out to users across the state. Personally, I feel that step 2, the proof of concept, was the most critical to our success in this implementation. For our proof of concept, we targeted the Esri JavaScript API primarily, and the results of that proof of concept are in this video you can see on the screen. As part of that proof of concept, we wanted to validate that the API could provide us with the features and the performance that our planners were after, and at the end of that proof of concept, we were satisfied that it would meet our needs. Our stakeholders were happy, our developers were excited to work with the Esri JavaScript API, and it fit alongside our existing Esri implementation. But that's not to say that we didn't hit some road bumps in those early days of the project. And some of those early road bumps that we faced included stakeholder buy-in. Now, we had stakeholders that were really excited by a new spatial platform, but we also had those stakeholders that were really familiar and comfortable with the existing technology stack, and they were resistant to change. So it was really important that we brought them along on the journey. Secondly, learning the API. The ArcGIS JavaScript API has a fantastic documentation online, huge amount of sample code, but it was really important that my developers spent the time to fully appreciate and understand how to use that API to the best of its capability. And that also went for learning about 3D data. We need to make sure we fully understood the different types of 3D data and what our planners actually needed. But the biggest one we encountered early on was that debate between a custom developed solution and a configurable off-the-shelf type solution. Because up until that point, all of our solutions have been configurable. And you can imagine the debate and the pushback of going down the custom path. But through that proof of concept, we were really able to validate that in this scenario, for this problem, we needed to go down the custom solution path. And I think the results at the end of the project validate that decision. So, the solution that we implemented basically is made up of 3 components, and the heart of that system is Vic3D. So Vic3D is a planning-centric, Esri-based 3D web application, which you can see on the screen here. I'll talk more on that in a moment, but in addition to that, we have a innovative parametric and generative 3D modeling service, which enables complex built form scenarios to be efficiently modeled using the planning controls as inputs. And thirdly, a gaming engine-based visualization capability using Unreal Engine, which allows us to generate highly realistic, immersive images and fly-throughs, which are really great when we're in consultations, workshops, and delivering media releases. Now, if we focus on Vic3D specifically, the application leveraged a range of tools and components across the Esri stack. And just to highlight some of the key ones, as I've mentioned, the ArcGIS API for JavaScript, fantastic range of functionality out of the box, exciting roadmap and comprehensive documentation. ArcGIS Solutions, it got flagged in the plenary yesterday, which was really good, but I feel that this is sort of an undervalued component in the Esri stack because it really delivers a great range of tools, and for us specifically, supporting our planning and development. If you haven't looked into the ArcGIS Solutions, it basically includes a series of targeted maps and applications which support you in leveraging your spatial data and the Esri platform to fast track projects, and it was really supportive in this instance. City Engine, it provided some really great and advanced 3D modeling capabilities, and also workflows that helped prepare and export our data out to Unreal Engine, which empowered us to develop those highly realistic fly-through visualizations. And that was something that up until this point in time, we were heavily reliant on external parties to deliver. So, sort of talked about the technology. I want to now give you a snapshot of how the users are leveraging Vic3D and the functionality that we've been able to build using the JavaScript API. So, as I mentioned, Vic3D provides our planners with an intuitive interface, a web-based application for reviewing development activity models across the city. To support the work and the analysis they undertake, planners utilize a mixture of data sets, including building models, realistic photo mesh models, and 3D planning scheme rules, for instance, building height controls. And they're all presented alongside our key 2D spatial data sets, for instance, planning scheme zones and the planning scheme overlays. Planners use the interface to easily review the results of our parametric modeling service, which is really important when undertaking precinct planning. And then development activity pins, which you'll see in a moment, show the current status of planning applications across the city and display the proposed building when selected. As part of the planning process, we quite often get multiple versions of a building model, and it's important that the planners can review the differences between those models on the fly. Overshadowing analysis, really important for our planners, especially when reviewing the impacts on the surrounding built form. And visibility assessment is really essential as well, looking at line of sight and viewshed analysis when you bring in that new building. When planners receive temporary building models, they can also bring those in on the fly and visualize them in that session, and they can also collaborate with one another using the commenting function. But when planners don't receive a 3D building model, or they need to visualize something on the fly, we give them this sketch ability so they can model up a proposed building, defining the building footprint, the number of floors, and then they can also introduce additional building segments with various setbacks. And once they're finished, they can then undertake overshadowing analysis or visibility and the likes. So hopefully that gives you a bit of an idea of the application itself. I want to now share with you some of the other user cases, the other user stories that we've been able to leverage the Esri 3D technology for. And while I could probably talk for hours on all the different projects, I'm going to focus on two in particular, one being a heritage project in the Buckland Valley, and the other one being a visibility assessment along the Great Ocean Road. So firstly, the Buckland Valley, it's in the Alpine region of Victoria, and back in 1853, they found gold in the Buckland River, and it was mined extensively through to the early 1900s. Fast forward to 2019, and the area was severely impacted by the Black Summer bushfires, and as part of the recovery efforts, the mapping of historical mining activity, we found there was a lot of inaccuracies in that existing mapping across the area. So Heritage came to us with a question: could we improve the mapping of historical mining activity through the Buckland Valley, but because we're in the middle of COVID lockdowns, all the work would need to be done remotely. So, in order to do that without being physically on the ground, we needed data that was detailed, accurate, and up to date. So we started by procuring a highly detailed LiDAR data set, and then using the Esri tools, we embarked on this project to not only improve the existing mapping of heritage sites across the Buckland Valley, but also try and identify new sites of historical significance. So we started out by combining our LiDAR data with the aerial photography. And while it produced a really impressive visual, it didn't give us a picture of what's actually going on beneath the tree canopy, beneath the vegetation. So we ventured into ArcGIS Pro to produce a series of derived products using that underlying LiDAR data set. We started with producing a surface image using the surface parameter geoprocessing tool, and that allowed us to determine the areas of steepest slope, which in turn helped us find mine shafts, areas affected by sleuthing, and also other man-made activity. In addition to the surface image, we also created a detailed hillshade using the hillshade geoprocessing tool. And that also created some really impressive visualizations, which supported us in identifying which areas had been impacted by the mining work that occurred. So, with the help of those derived data sets, we're able to locate and map new sites of heritage significance, while also improving the existing mapping of mining sites across the valley. And all that work was done from the luxury of our own homes. The end results were presented to Heritage through the Vic3D application, and over the course of the project, some of the new features of interest that we're able to identify included things such as so you'll see in a moment an old, it's a bit hard to see on screen, but there's an old railway track we identified. There's mining trails you can sort of see zigzagging up the side of the mountain, and also mining shafts that hadn't been located up until this point. So it was a really exciting project for Heritage to be able to find new and undiscovered mining activity across the area. Now, if we venture down to the beach now, the Great Ocean Road. The Great Ocean Road is an Australian National Heritage listed stretch of road along the southern coast of Victoria, and it's definitely a must-visit location if you ever do make it down to Australia. Being one of the most beautiful and scenic routes in Australia, it's really crucial that it's preserved from the impacts of overdevelopment. So, our planners came to us with another question. How can they assess the visibility of proposed developments at various distances from the Great Ocean Road? basically what they wanted to determine was, if they were standing on the Great Ocean Road, how visible would a new house be if it was at 2 kilometres or 4 kilometres or 6 kilometres? And that would form part of changes to the planning constraints across that area. So again, we dived into ArcGIS Pro to undertake the 3D spatial analysis, and we started by producing a raster product which highlighted the level of visibility at any point along the road. But it was complementing those results with the ability to virtually visualize the scenarios, literally as if you're standing on the road looking at the horizon to see how visible those houses would be. That really excited our planners. Being able to do that through Vic 3D was such a powerful mechanism, because they could sit down in a meeting with other planners and talk through the results, basically visualizing like you can see in the video. They had the high quality visuals, they had the stats, and then they were able to make the necessary changes to the planning rules in the area. So, beyond these projects, we continue to work really closely with our planners to try and identify new projects and new opportunities to leverage the power that we all have available in this space. For us, implementing an Esri-based 3D solution for planning was a really exciting journey, honestly can say that, and there's been a number of lessons learned along the way. For me, the biggest lessons I would impart on you guys is firstly data maintenance. In order for the platforms like this to be successful, maintenance of your data is key. You can't just have the data and let it sit there and grow old. So you might have really amazing tools, but if the data is if the data is inaccurate or out of date, users will look elsewhere. But that said, and we saw this again at the plenary yesterday, there's a lot of great functionality across the ArcGIS technology stack that supports the maintenance of our 3D data sets. You know, looking at things like ArcGIS Reality and the tools within Pro, not only supports easy data updating and management, but also change detection and elements like so. Staff investment as well. We wouldn't have been able to develop a platform like this without a highly skilled team. And we didn't inherit a highly skilled team. We really needed to invest in training and development opportunities for the group. And it's really key that we're all advocating for training and development opportunities for our spatial teams, because not only does it boost the team morale, but it also leads to the opportunity to create really impressive projects like that we deliver here. And finally, the collaboration point. The success of projects like this are heavily dependent on us working together, learning from one another, and also driving one another to bigger and better things. So, looking ahead, we're already starting to leverage some of the new and exciting 3D spatial data products that are available on the market. And we've started procuring these highly detailed street level mesh models like the one you can see on the screen here, which is a really impressive product from Aerometrics out of Australia. It's the quality of the street level views provided in this sort of data set that ultimately gives our planners an amazingly immersive experience when reviewing new developments like you can see on the horizon from the street. And they can do all of this without even leaving the office. You take these data sets and then you leverage the power of the integrations into Unreal Engine and Unity, and things just go to the next level, which I'll show in the next video. This video here, produced by Aerometrics using that same data set, just shows how highly realistic these visualizations can be when we combine our spatial data, the Esri technology, and the gaming engine space. I can honestly say that right now, the ArcGIS platform and the integrations it offers makes it easier than ever to develop a platform and utilize the functionality that we have available to us. So on that note, I just want to say a big thanks to my team back in Melbourne, who have been critical in the success of this project, and Aerometrics and the team at Esri that have been involved as well. Definitely welcome any communications around collaboration or knowledge sharing, or if you just want to check out what beers we drink down in Australia, you can check out the Instagram. But yeah, on that note, yeah, big thanks to everyone coming along this afternoon, and I hope you enjoy the rest of the conference.